Now let's get started with the 2 dimensions. Imagine you have a data set with 2 dimensions. Maybe in addition to daily minutes, you have years of data science experience. Of course, you would want to understand each dimension individually, but you probably also want to scatter the particular data. Well, in that situation, consider a fake data set which needs to be created over here as file. Consider for the new file, and this file will be saved inside our folder of Python scripts, and the name of the file will be the data set which needs to be created is the 2-dimensional data set, and we will be doing this now as 2-dimensional data set. Starts with the first import as import math, then comes is import random. After that comes from matplotlib import pyplot as plt. Then comes the collections. From collections import counter. Once these 2 sections has been done, so let's get started with the first function which was common over here is to get the inverse normal CDF and normal CDF. This was the normal distribution curve, and we will be calling this particular function in our code base. Then the next association comes into picture is about calling for a normal value, that is the random normal value. So that random normal value will be generated. So this is done in the statistical analysis as random normal value represented as return math dot, or we can represent it in other ways by calling the inverse CDF function. So it will return inverse normal CDF with a value of random dot random. This will help you to generate the random numbers, and after that we'll create the x-axis, that is for that comes over here with the x-axis as x equals random underscore normal for value represented as for value as in the specific range, value in range of 1000, and then we will start with the next value will be the next data set, because we are plotting it from the 2-dimensional way, so we will have a y-axis to be represented over here. So y-axis first, that is the ys1, will have a value as x plus random normal, and this will be divided by 2 for x in xs, and in the similar way we have ys2 equals a random value, say minus x plus a random value to be generated as random underscore normal with a value of divided by 2 for x in xs. So now let's scatter this particular plot over here, that is plt dot scatter, and the values as xs comma ys1 with the marker value as marker equals a dot value to be represented over there with the color as black, and then comes the label. The label associated over there is ys1, and then comes the next value to be scattered is based on the label ys2. So I'll take the same parameter. Here it will be taken with the color as gray and the label as ys2. Here the attributes will be again xs and ys2. Now let's get started with the label, that is plt dot x label with the value of X label as x's, and then comes the value for plotting the Y label as ys. So once this part is being done, we'll set up a legend, that is plt.legend. This will be taken with a value of local equals 9. And then comes the title, that is plt.title with the value as very different joint distributions. And then comes the value to be shown, that is plt.show. Now let's get started with the command prompt. So this is the command prompt, and over here I'll just run the code, that is plt dot with the Python value, that is python 2dimensional.py, and run the code. So this is how the various joint distributions is being depicted. If you see it or magnify the particular plot which has been plotted over here, the graph which is plotted over here, which is the scattered plot. So these plots help you to give the joint distributions, and this is the analysis when it comes to two-dimensional plotting. That imagine with the data set with 2 dimensions, with these dots, that is the darker dots mentioned, that is the black one is the first y-axis and the gray one is the next y-axis. Next chapter we'll analyze about these scattered plots. We had a look on these scattered plots. So consider 2 scattered plots being plotted in the same graph, how it will look. So that we'll have a look in our next chapter.